In this video, we're going to go over the KutaSoftware Infinite Pre-Calculus free worksheet, Transformations of Graphs. And the ways you would transform a graph, we're going to move it either up or down. You can move it left and right. You can expand it and compress it in both the vertical direction and the horizontal direction, as well as flipping it or reflecting it over the x-axis and the y-axis. So for numbers 1 and 2, it says to describe the transformations necessary to transform the graph of f of x, the solid line, into that of g of x, the dashed line. So looking at number 1, we can see right away that we have a reflection over this x-axis. So in order for f of x to be transformed into g of x, we need to reflect it across the x-axis. Now once we do that, we'll have a function here. So there's one other thing we have to do. We're going to have to move our function to the left. And we're going to move it to the left 1, 2, 3 units. And moving a function left, right, up, or down, we can consider that translating the function. So now, after we reflect it across the x-axis, we're also going to translate it 3 units to the left. So translate left 3 units. And then f of x will be transformed into that of g of x. The solid line will become the dashed line. Now let's move on to number 2. In number 2, remember, f of x is the blue line, and we need to see what we need to do with that solid line in order to get it to be the dashed line, g of x. Well, right away we can see a translation. It's translated up 1, 2, 3 units. So that's one step we will have to do, is translate up 3 units. However, once we have it translated up 3 units, 1, 2, 3, 1, 2, 3, and so on, just mapping out a few points. Here is f of x translated up 3 units, but we want f of x to be transformed into g of x. And note, in order to do that, we need to compress it vertically. This orange line that I just drew after our function is translated 3 units up needs to be compressed vertically. But by what factor or how much? So we're going to need to compress it vertically, and it's going to be by a factor of 2. And it's a factor of 2 because let's look at the points. Looking at this point, we're at 2, and the easiest way to see that we're compressing it vertically by a factor of 2 is that the slope of our f of x line is 1 over 1. However, in order to get to g of x, that slope, remember slope is rise over run, 1 unit up, 2 units to the right. So the slope of g of x would be 1/2. So we need to compress it by that factor of 2, going from a slope of 1 to a slope of 1/2. So we're going to compress f of x vertically by a factor of 2 and translate it up 3 units to transform it into g of x. And another way to think about compressing vertically, let's say that g of x had not been translated. So moving g of x down 3 units, g of x would have looked like this. And you can see from this graph that as opposed to having 2 for our y value of f of x, we now have 1. As opposed to having 4 as our y value, we have 2. As opposed to having 6, we have 3, and so on. So you can see that it is indeed compressed by a factor of 2. 2 divided by 2 is 1, 4 divided by 2 is 2, 6 divided by 2 is 3, 8 divided by 2 is 4, and so on. So it's easiest to figure out compression if you start from the same point, 0, 0 on each function, and see how much that function is expanded or compressed either vertically or horizontally. The slope happened to work out though because these were straight lines to one side. Let's continue on to our next section. Our next section for numbers 3 and 4, it says to describe the transformations necessary to transform the graph f of x into that of g of x. Now, as opposed to drawing this out, there's a few tricks so that we're aware of what kind of transformation is happening to the function. First, let's look at this value of 3. The 3 is multiplied to our function, the square root of x. Multiplying a number to a function, our function is the square root of x, so we're multiplying that 3 to the square root of x. When we do that, it's going to expand the function vertically. And it expands it by the factor of what that number is. So f of x is going to expand vertically by a factor of 3. So again, multiplying to the function itself expands it by a factor of whatever the value is. Now we've taken into account multiplying by 3, but it's not just 3 that it was multiplied by, it was a negative 3. And when you multiply by a negative to the function, you're going to be flipping it or reflecting it across the x-axis. So f of x will also be reflected across the x-axis. And again, that's because this negative was multiplied to the function itself. If the negative was multiplied to the x value or to the variable, then it would be reflected across the y-axis. However, the negative is multiplied or distributed to the function, therefore it's a reflection across the x-axis. And now, lastly, we'll take care of this minus 1 for g of x. Subtracting a number from a function will move it down. Adding a number to the function will move it up. So because we're taking away 1, we're translating that function f of x down 1 unit. If we had added or subtracted to the variable x itself, then that's going to move the function left and right. So to transform f of x into that of g of x, we need to expand it vertically by a factor of 3. We need to reflect it across the x-axis, and we need to translate it down 1 unit. Now, moving on to number 4, we have f of x equals x cubed, and we have g of x equal to 3 times x plus 1 cubed. Now, right away, we can note that this 3 is multiplied to the function. The 3 is not just multiplied to the x, it's multiplied to that entire function, x cubed. Therefore, we're going to be expanding it vertically. And the factor in which we're expanding it vertically is 3. And lastly, we can note that this 1 is added to x. However, the 1 is not added to the function, it's just added to the variable. So remember, if we added a number to the entire function, we're moving it up or down. But if we're adding a number to just the variable, we're going to be moving it left or right. Adding a positive number is going to move the function to the left. Adding a negative number is going to move the function to the right. So we are going to be moving this function to the left 1 unit. So translate left 1 unit. And that is how you transform f of x into g of x for number 4. So again, there are many ways to transform a function. So quickly I'm going to go over the ways to transform a function one more time. We can move a function up or down, and that's adding or subtracting a value to the function itself. We can move a function left or right. Moving it left is adding, and moving it right is subtracting, and that's adding or subtracting from the variable. We can also expand and compress a function vertically, or expand and compress a function horizontally. For expanding and compressing vertically, we're going to be multiplying to the function. to expand or compress horizontally, we're going to be multiplying to the variable, or what that function is in terms of. And then lastly, for reflecting the function across the x-axis, that reflection is going to be if we took the opposite or multiplied by a negative to the function. Reflecting across the y-axis will be if we multiplied the variable by a negative or took the opposite of the variable. But I want to note that for vertical expansion or compression, larger numbers expand and numbers between 0 and 1 compress. But for horizontal, the larger numbers compress and the smaller numbers, so numbers between 0 and 1, so fractions, will expand it. So if you want to, feel free to make a note of each of these so that you understand how we're going to be transforming functions. And if you want a more in-depth explanation, I will have a tutorial on that on my website, maemap.com, maemap.com. But for now, let's continue on to numbers 5 through 8, in which we're going to need to transform the given function f of x as described and write the resulting function as an equation. Unlike the previous problems where we were given g of x, we're going to have to solve for g of x. So in number 5, if we're expanding vertically by a factor of 3, that means we're going to be multiplying by a positive 3. If we were compressing vertically, we would be dividing by 3 or multiplying by 1/3. However, since we're expanding, we're multiplying by that whole number 3. And since we're going to be expanding vertically, we're going to be multiplying that 3 by the function itself because we're expanding vertically. And we're also going to be translating down 3 units. So we're going to be subtracting or adding a negative 3, and that negative 3 will be added, or 3 will be taken away from the function itself because we're translating vertically. So we'll start by multiplying by 3, so g of x will be equal to 3 times x squared, and then we'll subtract 3 from that to move it down. So g of x is equal to 3x squared minus 3 for number 5. So if you wanted to, we're going to be multiplying 3 by f of x and then subtracting 3. So we'll just take what f of x is, which is x squared, and plug that in. 3x squared minus 3. So again, reiterating, because we expanded vertically, we're going to be multiplying by that factor of 3. If we were compressing vertically, we would be multiplying by 1/3. Let's move on to number 6. In number 6, we're going to be compressing horizontally by a factor of 2. However, unlike compressing vertically, as opposed to doing 1 over the factor, we're going to be compressing horizontally, meaning that it's just going to be multiplied by that factor when compressing. And again, since it is horizontal, as opposed to multiplying to the function, we're going to be multiplying to the variable. So we're going to be multiplying 2 to that variable. We're also going to be translating left 3 units. So we're not moving up and down, so we're not adding or subtracting from the function itself. We're going to be adding or subtracting to the variable. And moving left, we're going to be adding. So x will get added with 3. And when doing a transformation, moving left or right, we're going to want that to be within the compression. So now g of x is going to equal 1 over, taking into account moving left, that's going to be x plus 3, and that new number, or what our new variable value becomes, will get multiplied by 2. Because if we multiply 2 to x at the start, that's not going to translate it left as we want to. So we want to translate left within those parentheses and then multiply by 2. So g of x equals 1 over 2 times x plus 3. So we're moving first and then compressing or expanding. So because we're changing the value of the variable by adding to it, we need to do that before we multiply, because 2 times x plus 3 is not the same as 2 times the quantity x plus 3. So we need to make sure that addition or subtraction for translating left and right is within parentheses before we do any compression or expansion horizontally. For number 7, our function is the absolute value function. So we need to expand it horizontally by a factor of 2. Expanding it horizontally means that we're going to be multiplying by the factor, but it's going to be multiplying by 1 over the factor to our variable. So because this is horizontally, we're going to be multiplying to the variable, and because it's an expansion, it's going to be 1 over the factor. We're also going to be translating to the right 1 unit. So that's going to be taking 1 away from the variable itself. So we're going to be subtracting 1 from x. But then we're also going to translate up 3 units. And remember, when you're translating up and down, that's adding or subtracting to the function. So f of x going up, we're going to be adding. So we'll add that 3. So now it's just time to write g of x. First, we'll deal with what happens to our variable itself. So within that absolute value function, we're translating, because remember we need to do that before we expand or compress horizontally. So we're going to have x minus 1, and that gets multiplied by 1/2 for the expansion horizontally. So now we have our new function expanded and translated to the right or left, but now we need to translate that entire function up, because that 3 gets added to the function itself. So then we'll add 3. So g of x equals the absolute value of 1/2 times x minus 1, and then plus 3. So expanding horizontally and translating horizontally, we're dealing within the function. Translating vertically or expanding vertically happens outside of the function or to the function at the end. Now for number 8, we're going to be compressing vertically by a factor of 3. Now, because it's vertical, it's going to deal with multiplying a value to f of x. And remember, when we're compressing vertically, we're going to take 1 over that factor. So 1/3 will be multiplied to f of x. We're also going to be reflecting across the x-axis. So reflecting or flipping across the x-axis also happens to the function itself. So we're going to take the opposite of that function. Translating right 2 units, remember, is going to happen to the variable. So within that function and moving to the right, we're going to need to subtract. So x minus 2. And then we're going to translate down 3 units. So we're going to be subtracting 3 units from the function f of x. So to our x variable, we'll start by translating it right 2 units. So we'll have the square root of x minus 2. Now remember, we need to multiply the function. So now the square root of x minus 2 is our function. We need to multiply that by 1/3 and by a negative. So we'll multiply by negative 1/3, which takes care of compressing and reflecting. And we had already taken care of translating to the right because that happened within the function. And then finally, we're going to translate down, subtracting by 3. So g of x equals negative 1/3 times the square root of x minus 2 minus 3. Now let's move on to numbers 9 through 12. For 9 through 12, we're going to be writing g of x, the dashed line, in terms of the solid line, f of x. So we're writing the function g of x in terms of f of x. So looking at 9, we can see we need to translate 2 units to the left. So we need to translate left 2 units. We also need to reflect over the x-axis. So our function will now look like this. And now we just need to figure out whether we're expanding or compressing horizontally. So if we were to think of g of x, if it was not reflected and not translated, we'd have one point at 0, 0. The next point, taking what is 1, negative 3, flipping it would be 1, 3, and then translating it back, you can see here, would be g of x had it not been reflected or translated. So you can see that that is a horizontal compression. So we're going to be compressing horizontally by a certain factor. Now we just need to figure out what factor that is. Now this function is the square root function. So at 0, the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2. However, we're compressing it. So you can see that if we're looking at 1, we are at 1/3 of that. As opposed to being at 4 for g of x, we're at approximately 1 and 1/3, which is 1/3 of 4. So we're going to be compressing by a factor of 3. So now, if we're translating left 2 units, we're going to be taking the variable and adding 2. If we're reflecting over the x-axis, then we're going to be taking the opposite of the function. And if we're compressing horizontally, we're going to be multiplying to the variable, but because the translation to the variable happens first, we're going to be multiplying to x plus 2, and that's by a factor of 3, and since this is compression horizontally, that will be the whole number 3. So now we just need to write g of x in terms of f of x. So g of x equals the opposite of our function, because that was the only thing done to the function itself. So we're going to take the opposite of f of 3 times x plus 2. So here are our transformations that happened within the function and the ones that happened outside of the function. So g of x equals the opposite of f of 3 times x plus 2. Let's continue on to number 10. In number 10, we're not translating left or right, but we are translating down. And that's translating down by 1 unit. So if we didn't do the translation, here would be g of x. So if g of x wasn't translated, let's go ahead and draw that. So moving this unit up 1 and this up 1 will help us see visually whether it's compressed or expanded. And we can tell that this is expanded to get to g of x horizontally. So it's a horizontal expansion by a factor of, now we just need to decide what that factor is. Well, when we're at 1 in the x direction, that expands to 2 in the x direction. And roughly when we're at 2 in the x direction, that expands to 4 in the x direction. So in order to get from 1 to 2, we're expanding by a factor of 2. Same with to get from 2 to 4, we're expanding by a factor of 2. So we're expanding horizontally by a factor of 2. Now, if we're translating down 1 unit, we're going to subtract 1 from the entire function. If we're expanding horizontally, that's going to happen to the variable within the function, and expanding horizontally, is going to be multiplying by 1 over the value of the factor. So multiplying by 1/2 to the variable. So now we can write g of x in terms of f of x, where f of x becomes f of 1/2 x, and then we're subtracting 1 from that. So g of x equals f of 1/2 x minus 1. So again, the transformations that happen to the variable happen within the function parentheses, and the transformations that happen to the function happen outside. Let's move on to number 11. So in order to go from f of x to g of x, we're going to move 1 unit to the left and 2 units up. So we're translating left 1 unit, and we're going to be translating up 2 units. And that's to go from f of x blue to g of x green. And once we translate, here is where our function is. So now we're going to need to flip these over the x-axis. So our next step would be to reflect over the x-axis. Now, translating 1 unit to the left, we'll be taking that variable x and adding 1. Translating 2 units up, we'll be taking the function and adding 2. Reflecting over the x-axis, we'll be taking the opposite, or multiplying the function by -1. So now when we write g of x, we'll say that g of x will be equal to that function, but as opposed to the function of x, it's now the function of x plus 1, but we need to take the opposite of that function, and we're going to add 2. Taking the opposite of the function takes into account the reflection, and adding 2 takes into the account translating up. So what happens to the variable happens within the function, so we translate it left within the function, and then outside of it happens outside of the function, which would be reflecting and translating up. So g of x equals the opposite of the function f of x plus 1, and then adding 2 to that. So the opposite of f of x plus 1 plus 2. Now on to number 12. In number 12, in order to go from f of x to g of x, we're moving to the left 1, 2, 3 units. So translate 3 units left. Then we're going to go up 1, 2, 3, 3 units. So translating 3 units up. And then lastly, we're going to need to reflect that function. And the reflection is going to happen over the x-axis. Because if we were to not have g of x translated, it would fall here. So that is indeed a reflection over the x-axis. But what all does this mean? Well, translating 3 units to the left means we're going to be adding to the variable and adding 3 to that variable. Translating 3 units up means that we're going to be adding to the function. And reflecting over the x-axis means we're going to be taking the opposite of the function. Now writing g of x will equal the opposite of f of x, which will be the opposite of x plus 3. And then we'll be adding 3 to the function. So first, we complete what happens to the variable, and then what happens to the function. Because what happens to the variable is within that function. So g of x equals the opposite, or negative, f of x plus 3 plus 3. For 13 and 14, we're going to need to identify the parent function f of x and then write an equation for the given function. 13, it's rather easy to identify that parent function because there are only so many functions that hit a point but stay positive afterwards on each side. And if you recognize it, the absolute value function has that shape of a V. So our parent function is f of x equals the absolute value of x. That is our parent function. But now we need to see what happened to f of x in order to make it g of x. Well, if we were to graph the absolute value function, we have 0, 0, 1, 1, 2, 2, and so on. Negative 1, 1, negative 2, 2, and so on. So now we can see what exactly happened to this function. Well, first off, it was translated 2 units to the right. And once it was translated right 2 units, you can see that it was compressed. Now, in order to see the compression, I like to redraw the function where both start at the origin or at a similar point. So without the translations. So we're just going to move this back 2 units. Now we can see the compression or the expansion, and we can tell here that it is expanded horizontally. So from 1 in the x, we're now at 3 in the x. So that is expanded horizontally by a factor of 3. So if we were at 2 in the x, expanding by a factor of 3, we are now at 6 in the x. So now we need to figure out what our two transformations mean in terms of the function and the variable. So moving 2 units to the right, we're going to be subtracting 2 units from our variable. So we're going to have x minus 2 now, and a horizontal expansion of a factor of 3. If it's horizontal, it's going to happen to the variable, but we've already translated the variable, so x minus 2. And for that horizontal expansion, we're going to be multiplying by 1 over the factor. So that will be 1/3 times x minus 2. So both transformations happen within the function, so to the variable. Therefore, we're going to have the absolute value of 1/3 times x minus 2. So the absolute value of 1/3 of x minus 2. Note that there was no transformations that happened to the function itself, so we're not adding or subtracting by any number or multiplying by any number outside of the function. And that's our solution in number 13. Now let's look at number 14. Number 14, if we can think of power functions, it's going to be an odd power because it's not symmetrical. But in order to figure out the parent function, let's first translate this back up 3 units. So it was translated down 3 units, so I'll write that. So now I'll redraw this function, translating the points back up 3 units. And like I stated before, we know that it's an odd power because it's not symmetrical. So we know our parent function, f of x, is going to be x to some odd power. However, we know that for our power functions, when x is positive, or the coefficient of x is positive, it starts from the bottom left quadrant and then continues into that first upper right quadrant. So we know that this function was also reflected, and that reflection occurred over the y-axis. So if we were to reflect it now over the y-axis, we can see what that parent function is. Because here we would be at the point 1, 1, and then when we're at 2 in the x, we're at 8 in the y. So 2 to the what power would give us 8? Well, we know that 1 to any power is 1, so 2 to the 3rd power would give us 8. So our parent function, f of x, equals x to the 3rd. Now we're going to use those transformations to write the equation for the function that's graphed, that blue line. So translating down, it's taking the function and subtracting 3, and reflecting is taking the opposite of the variable, so within that function. So the negative or opposite gets applied to the variable itself. So now we can write g of x. G of x, first applying what happens within that function, we're going to have negative x, and that will be cubed, since that's what the parent function was. So we simply applied our negative to our variable within our function. So now our function is negative x cubed, and we need to translate that function. So now we're going to subtract by 3. So we have f of negative x, and we're subtracting 3. So g of x equals negative x cubed minus 3. And that's the final solution on this worksheet. If you have any questions, please leave them in the comments below, or go to my website where I have a more in-depth tutorial on transforming graphs. However, before moving on, don't forget to like, subscribe, and share.